algebra is probably the most important topic in modern numerical methods. Let us see that what we are going to discuss in this course over next 2 weeks on linear algebra. Here and there I'll refer this textbook and I'll urge you to read certain chapters on textbook. And when I say textbook, what I mean is that this book by Chopra and Kanal, 8th edition, Indian edition. You can purchase this book. This is not very expensive. This is a very good book, covers all essential aspects of numerical methods. Linear algebra fundamentally does two things, at least for engineers. One is solving Ax equals B problem, that is the solution of linear equation. And the second problem that linear algebra deals with is Ax equals lambda x problem, that is the eigenvalue problem. In your textbook, eigenvalue problem is not discussed much. It is only in the context of differential equation eigenvalue is discussed, and that would be chapter 27 of your textbook. By your textbook I mean, once again, this is Chopra Kanal, 8th edition, Indian edition. Of course, linear algebra solution of Ax equals B problem, your textbook deals with that a lot, and in fact an entire part including several chapters are devoted to this. That is the part 3 of your text. We will complete linear algebra in 5 topics. The first is certain introductory concept which is not necessarily confined to numerical methods. Here we'll try to understand what is linear algebra. We'll get some basic concept of vectors and matrices which are at the core of linear algebra. Once we get our basics right, we'll get into the solution of linear equation, that is Ax equals B problem. And mostly we'll talk about Ax equals B problem, only a little bit eigenvalue problem we'll talk. So here we have direct linear solvers, then iterative linear solvers, then system of nonlinear equations. You may be wondering why we are talking about nonlinear equations since we are discussing linear algebra. But you will see that nonlinear equations, one equation we have solved using Newton-Raphson method or bisection method, but now we are talking about multiple equations with multiple unknowns, and there we need the treatment of linear algebra along with Newton-Raphson type method. So we'll look into this first 3 aspects. This will be related to Ax equals B problem, and then the eigenvalue problem, which is the Ax equals lambda x problem. So first we will have theory, then Ax equals B problems, and third Ax equals lambda x problem. We'll cover this in 2 weeks, that is week 3 and 4. Our focus here of course is not so much on theory. It is a mixture of theory as well as computer implementation. So we'll talk about some theory, but we will not go very deep into it. Quickly we'll come to computer application of Ax equals B and Ax equals lambda x problems. So as said, linear algebra will cover over next 2 weeks because this is a mixture of theory and computer application. Start writing your program. If you are not good at program, you think that you cannot write program, that's fine. Then you focus on pseudocode. Writing pseudocode doesn't require anything other than logical thinking. You can keep on writing that. As your exercise, you can go to your textbook, that is the Chopra Kanal book, and study this part 3.2, that is the mathematical background of linear algebra. And then if you can, write a computer program to multiply 2 matrices of arbitrary size. If you cannot do it, if you don't know how to multiply matrices, that is fine. We'll discuss it in due course. But if you can, you please try it. So that's all for this lecture. I'll see you in next class. Thank you.